Alright, this is the video for Part D of the summer packet, and Part D is about transformations of functions. I know you spent some time in pre-calc and you spent some time in my class looking at transformation of functions and what the role of different parameters can have on the shape of the graph of a function. So if we consider, f of x to be our parent, and there's a whole bunch of different parent functions you've looked at over the last couple years, be it linear, y equals x, quadratic, f of x equals x squared, cubic, x cubed, natural log of x, sine of x, you get it. The idea is we want to look now at what happens if we add some things to this function. What will it do to the shape of the graph? Well, if we take the function and we either add a or we subtract a outside of the function, outside the parentheses, that's going to be an up or down shift. So it's going to take whatever parent graph you have, and it's going to move it up or down a units. Compare that to something that looks like this. F of x minus a, f of x plus a. What that's going to do is that's going to shift it, but it's going to shift it horizontally. And it's going to go opposite of what you see. So what I mean by that is x minus a is going to go to the right a units, and x plus a is going to go to the left a units. Okay? They're really the big transformations that I believe you're going to kind of need for the packet. But there's a few others that we can talk about as well. Namely, what happens if we have a number outside a function, a times f of x? Well, that depends on the value of a. If a is bigger than 1, the graph is going to have a vertical stretch. If a is between 0 and 1, we have what we call a vertical shrink. In other words, the graph is going to kind of get pinched, if you will. Okay? The final thing would be reflections. So if you see negative f of x, that's a reflection on the x-axis. And if you see f of negative x, that is a reflection across the y-axis, and these are both reflections. Okay? I'm just doing this in general. I know in Algebra 2 we talked about it more specifically for each parent graph. I'm sure you did the same thing in pre-calc, more specifically with trig functions in pre-calc. Let's look at some example problems. I came up with some problems similar to the ones that are in the summer packet relating to transformations. So let's compare f of x, which is the square root of x, and g of x, which is the square root of x plus 4 minus 2. Okay, so f of x is your parent graph. I'm going to draw a rough sketch of it right here. That's the square root function that starts at 0, 0 and goes out to the first quadrant. Now, if you add these two different parameters, the plus 4 and the minus 2, it's going to do a couple things. We'll start with the plus 4. The graph is going to shift 4 units to the left. So now instead of starting at the origin, it's going to start at x equals negative 4. So it'll be somewhere over here. The minus 2 means it's going to go 2 units down. So instead of starting at negative 4, 0, it's going to really start at negative 4, negative 2. So somewhere down here, and then it'll take that same shape. Now, what if I ask you to write the equation of a graph that has the shape of x squared, but is shifted 2 up and 5 to the left? Well, we'll start with the 5 to the left. That means now instead of having x squared, we're going to have x plus 5 squared. And since we're going 2 up, we're going to add 2 to that. So that would give you a function that has that same parabolic shape as x squared, but now it's going to go 5 to the left and 2 up. Now in the final type of problem in this section, I don't give you an equation or a graph or anything like that. I just give you a point. And I ask you to see if you can come up with what the corresponding points would be on a shifted and transformed function. So let's do a set of problems similar to the ones that are on your packet that are like this. So suppose we have some function, we'll call it f of x, and we know that the point 3, 7 is on f of x, right? It's on that graph. So remember now the idea. F of x is a function. When you put 3 into that function for x, f of 3 is 7. That's what comes out of the function. So what that means is, I could ask you to tell me what would be the related point to 3, 7 on the graph of f of x plus 3. Now going back to the shifts earlier in the video, that plus 3 means the entire curve is going to keep the same shape as f of x, but it's going to move up 3 units. So that means we're manipulating all of our y-coordinates by a factor of positive 3. In other words, if I plug back in 3 for x here, and I want to figure out what the new f of 3 would be, I'd get the old f of 3, and I'd add 3 to it. Well, the old f of 3 was 7, plus this new 3 gets me 10, so that means what was 3, 7 on the original graph will now be 3, 10 on the graph of f of x plus 3. We'll do the same thing, but now let's put the shift inside the function notation. Let's try f of x minus 2. Now, as we've already talked about, this is a horizontal shift, and it's going to go in the opposite direction of the sign here. So f of x minus 2 means the graph is moving 2 units to the right. So we're not going to change the y-coordinate here, but we are going to change the x-coordinate. So what was at 3, 7 now moves 2 units to the right and becomes 5, 7. Now, if that doesn't make sense to you, put 5 back into this x. What do you get? You get f of 5 minus 2, which would mean f of 3 on the original function, and I gave you that the original value at 3 was 7. So 5, 7 now must be the new corresponding point for f of the quantity x minus 2. We'll try one more. What if I have some sort of scaling? So I ask you to give me what the corresponding point to 3, 7 is on negative 2 times f of x. Okay, again, we'll replace the x with 3. So we're doing negative 2 times f of 3. And we know that f of 3 is 7. So 7 times negative 2 is negative 14. So now again, the x-coordinate doesn't change. The only time the x-coordinate would change is if there's something inside that parentheses manipulating it, like in example B. So we're still at x equals 3, but now we're at y equals negative 14, because we did negative 2 times the original f of 3. And so 3, negative 14 is the corresponding point on the graph. Not sure if you've seen problems like this before, but I want to give you a taste of this type of way of looking at shifts, because really, if you understand the shifts, you can do it far more generally without being given an equation, without being given a graph. You can truly understand what each of those parameters will do to points along a function graph.